guys, today we're going to be talking about exponential growth and decay. So an exponential function is a function in the form of y equals a times b raised to the x power, where a is a non-zero constant, b is greater than 0 and not equal to 1, and x is a real number. So here are a few examples for you. Y equals, as you can tell, y equals a times b raised to the x power, okay? Or f of x, which also means y equals a times b raised to the x power. Okay, so those are both either exponential growth or decay. Problem 1, evaluating an exponential function. So evaluate the exponential function here for y equals 3 raised to the x power, for x being the numbers 2, 3, and 4. So we're basically just plugging in those x values that they gave us, or in other words, the domain value. You can kind of think about it, if you want to, as, so I'm going to plug in the 2 here. Notice 3 squared equals 9. So our y value then is 9. Here we get 3 raised to the third power, which is 27. And then here we would get 3 raised to the fourth power is 81. So now let's find what the common multiplier is. So notice we're going to take 27 and divide it by 9, and we get 3. And so what that tells us is that's our b value, which notice you can actually already see right here in the equation itself. So the question is now, so what's a, the initial value in our problem? Notice our a value would have to be equal to 1. So y equals 1 times 3 raised to the x power. Applying exponential functions, suppose two mice live in a barn. The number of mice quadruples every 3 months. The function f of x equals 2 times 4x models the situation. How many mice will be in the barn after 2 years? So I'm going to go ahead and just rewrite our problem. Y equals 2 times 4 raised to the x power. Now, what I need to first ask myself is, in 2 years, how many 3-month time periods are there? There are 8 3-month time periods in 2 years. So what we're basically saying is that we're going to make our x here equal 8. So let's just plug that in. Y equals 2 times 4 raised to the 8th power. So let's go ahead and simplify this. Y equals, remember, according to order of operations, we do with exponents first. So 2 times, what is 4 to the 8th power? We get 65,536. And then finally, for our final answer, multiply that by 2. So there would be 131,072 mice after 2 years in the barn if they continue to quadruple every 3 months. Number 3. The function f of x equals 1.25x models the increase in size of an image being copied over and over at 125% on a photocopier. Graph the function. So notice we're going to go ahead and plug in our x values that they give us, where the exponent is, because according to here, okay, that's where it goes. X is the exponent. So let's see if we can just plug those in. So that would be a 1, 2, 3, 4, and 5. Notice we already kind of get the answer here, and we're going to just basically kind of just round it and give the approximate answer. So we'll just say this is about 1.3. This will be about 1.6. This will be about 2.0. Keep that at 2.4. And this would be 3.1. So notice here I'm actually going to write these as ordered pairs. So the x value is 1 and my y value is 1.3. X value is 2, y value is 1.6, x value is 3. Y value 2, x value 4, y value 2.4, 5 is the last x value, and 3.1. 1. So remember here, to find the b value, the common multiplier, we're taking that 1.6, we're going to divide it by 1.3, and when we do that, we basically get about 1.23, which, notice it should be actually relatively close to 1.25. So 1.25, our a value, again here, our a value is equal to 1. We can go ahead and graph these points. I'm going to pause the video and graph the points. That way you guys can see what it would look like. You guys can do the same thing. So our graph should relatively look like something like this. So notice we can see that it is exponentially growing over time. Okay? Alright, next part. Evaluate each exponential function for the domain of x being -2, x being 0, and x being 3. Notice domain refers to x. Okay, so we're basically just going to go ahead and plug this in here. 4 raised to the x power, 4 raised to the x power, and 4 raised to the x power. Notice I'm treating this like 3 separate problems, okay, because I have 3 different x values that I'm using here. So -2, 0, and 3. So I'm going to write what we get down below. Alright, so when I did that, 4 raised to the -2nd power gave me 0.0625. When I did 4 raised to the 0 power, that's 1, and 4 raised to the 3rd power is 64. So I can tell here that the a value is 1 and that the b value is 4. Next one, same idea. So let's go ahead and break those down. I have 10 times 5 raised to the exponent of -2. So let's see what we get there. And I notice that we get 0.4. So now I'm going to do the next one. So now when I have 10 times 5 raised to the 0 power, well, I know 5 raised to the 0 power is 1. So 10 times 1 is 10. And then finally, the last situation would be 10 times 5 raised to the 3rd power. And that is 1250. Oops. Close out the bracket because that's my range. Alright, A is 10, B is 5. Alright, let you guys do C on your own. So make sure you pause the video and try that one on your own. Number 2, suppose a population of 10 animals quadruples every year. Use the function f of x equals 10 times 4x. How many animals would there be after 6 years? Notice they quadruple every year, so we don't really have to break down 6. 6 is our x value here. So all we have to do is plug it in. Y equals 10 times 4 raised to the 6th power. And let's see what we get when we do that. And the answer would be 40,960 animals after 6 years. Alright, so a few more vocabulary and key concepts. We're going to be talking about exponential growth, and exponential growth can be modeled with the function of f of x equals a times 1 plus r raised to the x power. Notice the 1 plus r is also known as the b value. Okay, remember a is your initial value. The b, which is greater than 1, is the growth factor. Then we have over here exponential decay, which is a little different. Notice the only difference really in the equation is that there's a 1 minus r, okay, so that goes for decay. Alright, so number 1, compound interest. Suppose you deposit $1,000 in a fund that pays 7.2% interest compounded annually. Find the account balance after 5 years. So notice this is an exponential growth problem, okay, where y equals a times b to the x power, where y equals a times 1 plus r. Notice the 1 plus r represents the growth rate raised to the exponent. So there's a few things that you have to know first, and that's what your a value is, what your rate or growth rate is, and what is your x. So let me go ahead and write that down. Alright, based on the problem here, a is 1,000 because it is my initial value, okay, my starting point. B is the 7.2% growth rate, because that's how we're growing here. But notice what I have to do to that is I actually need to change that from 7.2% to decimal, going to be 0.072. X, okay, my little exponent is represented by the time, or the years in this case, which is 5 years. So now all I'm going to do is I'm going to plug it into that equation. So when I plug it in my formula, I get 1,000 times 1 plus 0.072 raised to the 5th power. So now I just got to put that part in my calculator, and I can get my answer. So we basically come up with, after 5 years, the new account balance would be $1,415.71. So let's try another one. Suppose the interest rate on the account in example 1 was actually 8%. How much would it be in the account after 18 years? So notice we're keeping the same A value, okay, but we are changing our B value to 8%, which first we need to change that into a decimal, and that'd be 0.08. And we're changing our X to 18 years instead. So let me go ahead and plug it into my formula. And I get y equals 1,000 times 1 plus 0.08 raised to the 18th power. Like I said, put that in our calculator and see what we get. And our answer is that we would have $3,996.02 after 18 years with an interest rate of 8% instead of what it was in the previous problem. Alright, one little thing to think about when you're doing decay problems, okay, is that when a number is decreased by 5%, the result is 95% of the original number. So when you find the decay factor, think 100% minus the percent a number is decreasing. So here's the decay problem, milk consumption. Since 1980, the number of gallons of whole milk each person in the United States drinks each year has decreased 4.1% each year. In 1980, each person drank an average of 16.5 gallons of whole milk per year. Write an equation to model the gallons of whole milk drunk per person. Alright, so a few things you have to know from reading that problem is that A is our initial value, which is the 16.5 gallons of whole milk per year. B is our decay factor, which, remember, as I mentioned before, when we do decay, we have to take 100%. Like I was saying, you have to subtract 100% from whatever the decreased amount is. So we have to take 100% minus 4.1% because that's what the decrease was, okay, according to our word problem each year. And that would give us a new total of 95.9%, which, remember, we always have to change our percents into decimals, which comes down to 0.959. X here is going to be the number of years since 1980. Notice they didn't give us a specific year, so all they're asking us to do is to write the equation. So we're just going to plug it into y equals A, 16.5, parentheses, 1 minus, because it's decay, the 0.959 raised to the x power. We're going to leave it as x because we don't know what the year is. Part B, though, use your equation that we just wrote to find the approximate consumption per person of whole milk in the year 2000. Now remember, X is the number of years since 1980. So year 2000 to 1980 is a difference of 20 years. So we're talking about 20 years difference, which is our X value. Okay? You think about it in that sense. Okay? So you get 20 years. So let me rewrite my new equation then, because I know that X now is actually 20. Raised to the 20th power. Now I can put that all in my calculator and see what we get. And our final answer is basically that we would have 7 gallons per person in the year 2000. There's another page added on yours. You guys are more than welcome to go ahead and work that out on your own, and if you turn that in, that's actually the bonus. So if you do that, that'll give you some extra points. The secret word is going to be decay.